Hello, everybody. This is 1.2b lesson. We're in rational numbers ordering and estimation, which means we're really going to be taking a look at fractions between 0 and 1 and their kind of value on a number line and in relation to one another. Okay, so we're looking at this number line here. We're not going to focus on this negative side yet, but it's important to understand that there is a negative side. So notice that all of these are positive fractions, and it says to plot them on the number line below. So the first thing we need to do is we need to see what the scale of this number line is. And there are 10 little, we're going to call them tick marks. So this would be 1/10, 2/10, 3/10, and so on. Okay, so 1/2 is equal to 5/10. So here's where 1/2 would be. 1/3, 1/3. Okay, so 1/3 is 0.3 repeating. So 0.3 repeating is between 3/10 and 4/10, not quite halfway. Okay, so 1, 2, 3. So right about there is 1/3. Okay, 3/4. 3/4 is 0.75 or 75 hundredths, which means it's going to be between 7/10 and 8/10 on this number line. So if this is 5/10, 6/10, 7/10, 8/10. So right between these two would be 3/4. And then 2/5. 2/5, if we think of this in tenths, 2/5, we change the 5 into a 10, that would be multiplying the 5 by 2. So 2/5 is equivalent to 4/10. So 1, 2, 3, 4. I'm going to write that one down here, and I'm not writing 4/10. I'm going to write 2/5. You always want to reference exactly how they're given to you in the problem. Okay, now we're going to compare the fractions using this symbol is a less than symbol, and this is greater than, and this is equal to. Okay, so 1/2 and 1/3, we're comparing those two. 1/2 is definitely larger than 1/3 simply because 1/2 is to the right of 1/3 on a number line. Okay, so we're just going to tuck in a 1/2 is greater than 1/3. Okay, take a moment and try this one on your own. Pause me and then come back when you're done. All right, so this guy, 2/5, is right here, and 3/4 is right here. 3/4 is larger, 2/5 is smaller. So this says 2/5 is less than 3/4. Again, simply because the 3/4 is to the right of 2/5 on that number line. Okay. Number 2, what is the difference, or what differences do you observe when comparing the fractions in part B? Okay, it's exactly what I just spoke about. So we kind of look and pay attention to what's on the right of and what's on the left of. Anything on the right of is greater and anything on the left of is less than. So I'll just jot a couple notes down here in relation to these numbers here. So 1/2 is to the right of 1/3 on a number line. And then we could say 2/5 is to the left of 3/4. Okay, it doesn't matter which way we go. We could have easily said this one 1/3 is to the left of 1/2 on a number line. So either way. So 2/5 is to the left of 3/4 on a number line. Okay, how does the number line help you determine which number is larger? Okay, so let's just make a generic statement without using these fractions. Numbers to the right on a number line are always larger than those on the left. Okay, so there's a generic statement that's true for any number on a number line, okay? All right, so number 4, looking at all those fractions, it's a bit overwhelming, okay? I'm kind of overwhelmed at all those numbers. Okay, notice that we're going to categorize them as close to 0, close to a half, or close to 1. And then number 5 wants us to order them from least to greatest. Okay, looking at all of these, it's a lot. Okay, but if we take and categorize them first, wouldn't it make sense that we could then order these because they're smallest? Then we'd order just these. They're the next size up. And then these guys are the largest. Okay, so that kind of makes little mini problems out of this big giant problem. Okay, so let's just take them as they come. So 1/2, well, it's close to 1/2. It is 1/2. I'm going to kind of cross them off as I go. 1/9, that's teeny tiny. 1 part out of 9 whole. That's small. That's close to 0. 5/8. 5/8 is very close to a half. 4/8, right? 4/8 is a half. So 5/8 is pretty close to a half. 5/6, 5 parts out of 6 whole. That is almost 1 whole. Same with 7/8. That is almost 1 whole. 1/5, it's very close to 0. 1 part of 5, that's small. 5/9. 5/9 is very close to a half. Okay, 4.5/9. I know that seems weird to have a decimal and a fraction when we think about it, but 4.5 is exactly half of 9. So that is pretty close to a half. 3/8. 3/8 is pretty close to 4/8, which is a half. And then 1/7 is teeny tiny. So 1 part of 7 tucks in over there close to 0. Okay, now it's not such a hard task. We have 3 to compare. Then we've got these 4 to compare, and then we've got the 2 to compare. Okay, so 1 part of 9 is the smallest. If you put that in a calculator, 1 divided by 9, that decimal value would be much smaller than 1 part of 7 would be next, and 1 part of 5. Okay, now close to a half. Let's go ahead and look at these. So a half is exactly 5/10, 0.5. Okay, this is a little larger because 5/8 is larger than 0.5. 4/8 would be 0.5. 5/9, that's a little larger than a half. And then 3/8 is smaller than a half. So 3/8 is the smallest one in that group. And then 1/2. Now the question is 5/9, is that next? Or 5/8? Okay, I'm not quite sure. And without a calculator, we're going to think about this without a calculator. Let's do 5/8 first. 5 divided by 8. Okay, that's how you would set that up. 5 divided by 8. So we're going to add a couple zeros and a decimal here. 8 goes into 50. 6 times, 48. 8 goes into 20. 2 times, 16. 8 goes into 40. Okay, so 0.625 is 5/8. Now let's do 5/9. 5/9, 5 divided by 9. That means the 9 is outside there, dividing into the 5. All right, 9 goes into 50. Not 6 times 4. Let's see here. 9 times 5 is 45. Okay, so right away we can see which one is smaller and which one is bigger. I don't even need to continue this division. I already can tell. Okay, so I'm going to have my 5/9 here and my 5/8 here. Okay, now the last two. Again, they're too close for my brain to think about 5 parts out of 6 and 7 parts out of 8. So I'm going to have to do a little long division problem. I'm going to scooch and do that right over here. So 5 divided by 6. 6 goes into 50 8 times. 48. 3 times 18. Okay, now we're just going to keep getting that repeated too. So that means this 3 is going to repeat. All right, let's try the 7/8. 7 divided by 8. 8 goes into 70. 8 times 64. 60. 8 goes into 67 times. Okay, well, I'm not gonna carry this on because I can already see which one the bigger one and which one the smaller one is. So 5, 6, 5, 6 is smaller and 7/8 is larger. Okay, that's how you would handle a problem like that. All righty. Number 6. So it says to approximate where each value is located on a number line below. State a common fraction and decimal you can use to help you find the approximate location for each. The first one is done for you. Okay, well, so letter A, 0.32 is really near 0.3, 3/10. It's also pretty close to 1/3 because 1/3, remember, is 0.3333 forever. Okay, so we can use any one of those to, gotta love the word approximate. Okay, so we will talk, and again, we've got nothing going on in the negatives in this chart. Everything is going to be between 0 and 1. And again, our scale is in tenths. Okay, so 0.32, well, here's 0.3. So we're going to have it be just a smidge. I'm going to label that with an A, just marking that letter of it. Okay, 0.67, we can think of that close to, and this little squiggly equal means roughly, about. Okay, so we can think of that as 6/10 repeating. We can think of that as about 2/3. Okay, well, 0.6 repeating is going to be between the 6th tick mark and the 7th tick mark. 1, 2, 3, 4, 5, 6, 7, and it's a little over halfway. So I labeled that with a B. That is not a 6, that's a B. Okay, this guy right here, see? This is awfully close to a quarter, 75 hundredths. Okay, so 75 hundredths reduces down to 3/4. Okay, so again, this is going to be between the 7th and 8th tick mark, right between. So 1, 2, 3, 4, 5, 6, 7, 8. That's going to be labeled C. This is very near 1 whole. So 1 whole, just shy of 1 whole. We're going to tuck it in right there. That's D. This guy right here is very near 2/10. A little under. So here's 2/10. Here's 1/10, so a little under 2/10 would be like right there. So I'm going to label that with an E. And then 0.06, that's 6/100ths. Okay, well, 6/100ths, that's teeny tiny in this region here. So let's think of that as roughly 1/10. Okay, now here's the scoop. 1/10 is right here. Okay, so we are going to be a little bit over halfway, it looks like, in there. And that's going to be labeled an F. Okay, let's take a look at number 7. It says plot each fraction on the number line, fill in the blank with a is less than, is greater than, or is equal to. Okay, so I've got my 4 3/10. So again, we're looking at tenths. So here's 4 3/10. I'm going to mark that 4 3/10. Okay, now 4 2/7. 2/7 I'm not quite sure, but I know 2 divided by 7. I'll have to add a decimal and some zeros here. 7 into 20, 2 times. Okay, can you already see that this is going to be just left of this guy? Okay, so I'm going to come in and mark that with my orange pen here. It's to the right of 0.2, but it's going to be to the left of 0.3. So somewhere in the middle there, 4 2/7. Okay, so 4 2/7 is smaller than, and the 4 3/10 is larger than. So depending how you read this, 4 3/10 is greater than 4 2/7, or you could read it backwards. 4 2/7 is less than 4 3/10. Okay. All right, let's go ahead, direction shift just a touch here. It says to plot each fraction on the number line, fill in the blank with it is less than, is greater than, or is equal to. How do you know your answer is correct? Okay, so we know that this guy is 0.14000. We know that this guy is 0.1444. Okay, so we're going to be comparing that thousandths digit. Notice that the tenths digit, 1 is the same. The hundredths digit, 4 is the same. So we need to go out to the third digit to the right of the decimal, which is the thousandths position. Okay, so notice our number line here goes by, it looks like, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 10 again. So 1, 2, 3, 4. This guy right here is going to be the 0.14. And then just a hair past is 0.14 repeating bar. Okay, so we need to make that one be the larger one. Okay, and I'm going to simply revert back. My justification every time is 0.14 repeating bar is to the right of 0.14 on a number line. Okay, I could have said 0.14 is to the left of 0.14 repeating bar on the number line. So either way is fine. Okay. All right. Why don't you pause and try number 9 and 10 on your own, and then click me back on when you're ready to hear the answer. Okay. All right. So 3 divided by 20. 20 goes into 30 one time. 20 does not go into 10, so we need to bring down another digit here. So 20 into 100 goes 5 times. All right, so, whoopsies. Scratch that. I took a 0 up when I should not have taken a 0 up. It came down. Okay, so 0.15. Now, if 3/20 is 0.15, that is equal to. Okay, and 0.15. Okay, so this is 0.1, this is 0.2, so this is 0.15, and it is 3/20. They are the same number. Okay, so I'm going to just say these are equivalent numbers. Equivalent numbers. Okay, this guy, 2 2/3. Well, 2/3, you should know by now that that is 0.66666666. So 0.6 repeating. Okay, this is 2.60. Okay, so 2.60 is right here. Again, these are by tenths. Okay, and then the 2 2/3 is a hair past. That's 2 2/3. And again, we're always writing on the number line exactly how it's given. Notice I did not write 2.6 repeating bar. That's not what that is. Okay. All right. So we've got 2 2/3 is larger. So 2 2/3 is 2 to the right of 2.6 on a number line. Okay. All right, and you guys are definitely marking any questions that you have for when we discuss this in class, so you know and you remember what your questions were. Okay. All right. All right, so go ahead and pause me. I'd like you to try number 11 and 12 on your own, and then when you're ready to hear answers, go ahead and click me back on. Same kind of idea, but it's just kind of a sentence instead of a problem-looking type thing on the last few. All right, so 74 hundredths is to the left of, this would be 75 hundredths. Okay, so 0.74 is to the left of 3/4 on a number line. Since numbers on the left are smaller than numbers on the right. Okay, this guy is 1.26 to the left or right of 1 1/4. So 1/4, you should know, is 0.25. Okay, this one's a smidge bigger. So 1.26 is to the right of 1 1/4 on a number line. Since numbers on the left are smaller than numbers on the right. Okay, number 13, for each problem below, circle which number is bigger. Explain how you know. Okay, so we're going to be looking at place value, digits in different place values. So just because you see two numbers here doesn't necessarily mean it's bigger. Okay, so let's go ahead and compare the tenths digit, 4 and 0. This is definitely the bigger one. Okay, so I compared the tenths digits. 4 is larger than 0. This guy, okay, the tenths digits here, 2 and 3. Okay, don't be thinking 27's bigger than 3. That's not how that works. You need to look at place value. Okay, so this guy's definitely the bigger one. Again, I compared tenths digits. The 3 was larger than the 2. Okay, and on this guy, don't be thinking 9 is bigger than 1. I'm looking at the tenths digit again. Boom, that one's bigger. Okay, so I compared tenths digits. 1 is larger than 0. Okay. All right, number 14, the last one of this lesson. I think that's it. Yep. Without using a calculator, determine which fraction is bigger in each pair. Justify your answer with a picture and words. Okay, so let's take a look at this. 1/3. So I'm going to make two rectangles as close in size that I can. Okay. All right, 1 part of 3. Roughly that. 1 part of 2. Roughly that. Okay, you can clearly see 1 part of 2 is larger, a larger amount shaded than 1 part of 3. Okay, so 1/2 has a larger shaded area than 1/3. Okay, let me do 3/7 and 3/5. I'm going to do that one like this. Okay, and again, we're humans, but we try to make them as close to the same size as possible so that we can compare which one has more shade. Okay, now 7 total boxes. 1, 2, 3, 4, 5, 6, 7. Okay, 3 of these guys. 1, 2, 3. Next one is 5. 1, 2, 3, 4, 5. 3 of them. 1, 2, 3. So the 3/5 is larger for the same reason we said the last one. 3/5 has a larger shaded area than 1/3. Okay. All right, again, bring your questions with you. Hopefully you marked up and put stars or circles or question marks or something by things that you would like emphasized or re-explained in class together. Okay, thanks guys.